about to go over some of it. All right, so let's talk about number 8. Seems like most of us have gotten almost all the way done. Number 8, what did y'all say? Linear, exponential, or neither?
Linear.
Linear? Why?
Constant rate of change.
Okay, here's the issue, and this is something I need you to be aware of. Most teachers have talked about a constant rate of change your entire life. However, both an exponential and a linear function have a constant rate of change. What type of constant rate of change? Is it additive or is it multiplicative?
Additive.
That's what we need to focus on. What is your additive rate of change?
9. Negative 9.
Negative 9? I see a negative minus 18 right here.
And it's 2 on the x.
But it's 2 on the x. And so we consistently see this idea of repeated addition and subtraction happening here. Right? Notice if we think about common difference or a slope, right? If it's a slope, it's rise divided by run. Negative 9. There's a slope. And that would make sense because if I put these extra x values that I'm missing inside of here, there they go. Okay? And so now we can see that common difference of minus 9. Did anyone make a graph of this? No? Negative? Yeah, a lot of students are very hesitant to create graphs, and I don't know why y'all keep...
Man, I haven't got one.
Did you?
Yeah,
You're working on it?
We still putting points on it.
One thing I will remind you is you don't have to go by ones. So negative 2 comma 23, I'm going to look at it right around here. 0, 5 would be here. Bless you.
Thank you.
5, 10, 15, 20, 25, 30, 35, 40. Okay.
45, 50.
Okay. So 2, negative 13 would be somewhere around here. 4, negative 31. So you tell me, does that look linear?
It does to me.
It does. But what was making this thing linear? Why is this graph linear? Right. We need to remember this, and this is something we want to start to recognize and making sure that we look at regularly, is that there's an additive rate of change. That's what's really defining this thing, right? A common difference over equal intervals. Notice it was truly a slope of negative 9, but it kept being minus 18 over an interval of 2. So it was going to be linear. This idea of a common difference over equal intervals is what's really defining this linear function. Now that I know my slope, I could actually write this equation. Did anyone write the equation for this, by the way?
Negative 2.
Anyone know where I got this from?
9. No.
What is my additive rate of change? I'm repeatedly adding a
9.
negative 9. That's why I'm subtracting 9, right? How do we show repeated addition?
Multiplication.
So I multiply it by x. What was my y-intercept?
5.
5. That's where I got this information. I could have started anywhere. If I had written it as f of x, I could have started at 23. And then I'm repeatedly taking 9 away from that 23, but it'd be x plus 2 times. That's kind of closer to the idea of point slope. There's lots of ways to write this, but we need to engage our brains for sure and keep focusing on this. But this is the key thing we need to recognize, right, Caroline?
Mm-hmm.
Mm-hmm. However, this is one that gave a lot of students a lot of trouble. But that's because we were very hesitant to do the simplest thing for number 9. Personally, I don't see an equation here that I could easily write, because it's all over the place. But what's a mathematical representation I could create? I can make a graph. So I got to get it all the way out to 74, so I'm going to go by 5s. Man, I really have to go out there. Guess I should just start closer. So 50. All right, so there we go on the X for the height in inches, and then we got the shoe size. 2, 4, 6, 8, 10, 12, 14. So height of 62 inches gives a shoe size of 6. Okay. A height of 74 inches gives a shoe size of 13. Height of 70 gives a shoe size of 9. Did I just skip 70? Be way easier with graph paper, but right, so far it's looking a little linear, but then 67 has a shoe size of 11. Does that look linear to you?
That just don't make sense.
Well, it's called a scatter plot. It's not a linear function or an exponential function. It's got random points. 53 and 4. And 58 and 7. So, I mean, it's just not linear and it's not exponential. But, I mean, if you graph that, can you clearly tell that, hey, there's no linear rate of change or exponential rate of change? Really? Because it doesn't look like you're even looking at it. It looks like you're busy drawing things instead of using the graph paper for what it was designed for. Okay, number 10. Linear, exponential, or neither? Exponential? Why? Say again? Okay, why does percent of make you think that it's going to be exponential? How do you know? I don't see it tell you to do that. Okay, so we're dealing percent of something, right? That does tell you to multiply. What are you multiplying by each time?
1.75.
What did you say, Caroline?
1.75.
She said 1.75. Why did you say 0.75?
I actually just said 75.
Oh, so we're just multiplying by 75?
Nope.
What are we supposed to multiply by here?
0.7.
Y'all are having actual conversations just not even 10 minutes ago, and then I get up at the front to ask y'all questions, and we just start silently sitting here like we have no ideas?
0.75.
Okay, why 0.75, Zay? Okay, let's say we're looking at our years and we got our people. Year 0, there's 1,000 people. If I go to year 1 and I multiply by 0.75, I'm going to get 750. Is that increasing? It's decreasing. That's not what's supposed to be happening. We need to remember, if I have all of the people here, all of them, what percent is that? 100%. Then it's increasing by 75%, so we now have 175% of the previous year. Now I get 1,750. Is that increasing? And so please notice, and this is a detail that a lot of us missed, if you're repeatedly multiplying, what do we call the thing that we multiply by? It starts with an F.
Fraction.
Sometimes. How about a,
Factor.
guys, if you have factors, what do you do with factors?
Multiply by them.
You multiply by them. A common ratio is a factor. You need to keep that in mind. We'll pick back up with this tomorrow and wrap it up. We need to make sure we're identifying linear and exponential functions. That's what it's all about. If you have not finished the task, I'm going to check to see if it is finished tomorrow when you come into class. We are also going to have some vocab tomorrow that I'm going to be checking. Complete the examples and notes and connections within this unit and the personal definition for domain through exponential function. It's 3 words, it's 2 columns. You need to have this done before you come to class.
Wow.